we go for the mold design, we also think about the material, that what material are we going to make, what material we are going to choose actually for the mold design.
Choose for the product.
For the
Yes.
so that is a very crucial thing, and there are many more I will say many more processes are involved when we are going to manufacture a mold. Designing is one part, but manufacturing is another part.
Yes.
Okay, so here are some things which I will share with you. Most commonly
Right.
used mold scale. Are you
Yeah.
able to read now?
Yeah. Yeah. Yeah.
Okay.
I can see. Pre-hardened mold and holder steel.
Mhm. Okay, so the steel types most commonly used are pre-hardened mold and holder steel, through hardening mold steel, and corrosion resistant mold steel. These are some
Right.
categories which we balance when we going to choose the material for a mold. Like
Yeah.
the material, sometimes we go for pre-hardened material, that is a little bit
Right.
hardened, and then after that we start machining. And second thing is
Right.
through hardening mold steel. So through hardening means we are going to through hardening the material. You are you
Okay.
aware of the through hardening process?
I'm aware of. Yes. Yes. Clear.
Through
I can
hardening means
understand because
uh,
it is like you're completely not fully completely hardening the process, right?
through hardening means we are hardening throughout the material. Whenever wherever you will check it out, you will get the same hardness throughout the material, whether it is the top surface or whether it is the core of the material. The hardness
Okay.
will be the same. That is called
Right.
through hardening.
It's the same.
That means throughout the
Right.
material we are going to harden the material.
Okay.
Okay, and another thing is case hardening. Case hardening means
That is just to the outer section.
outer surface, yes. On the outer
Or
section you are going to harden the material, and
right.
that may vary as per the application. Sometimes people go for 1 mm, sometimes people go for 0.5 mm, so it depends that what are their application. But here,
Right.
in case of mold and dyes, we go for
Yeah.
through hardening, because the material wear out when we use it continuously. So it is important that the
Uh-huh.
material should be through hardened.
Okay.
Okay, and second thing, corrosion resistant mold steel. There should be some corrosion resistant element should be added into the material,
Right.
so that during the process or for a long time the material should not corrode after the application,
Okay.
multiple applications.
Okay.
Okay, so the material should be corrosion resistant through hardening. And when
Right.
to use pre-hardened mold and holder steel? Uh,
Yeah. Can you explain a little about this holder steel? What is that holder steel? Pre-hardened. Pre-hardened is like it's soft material, right?
the pre-hardened means we are going to use the material, sorry, we are going to machining before we are going
Uh-huh.
to harden the material. That
Hardened.
means material is already hardened, pre-hardened, and then we are
Okay.
going
Okay.
to go for machining. I will take this thing in a 2 or 3 pages after, because there is a more elaborative slide over there, so I will tell you about it.
Okay.
Okay,
All right. Okay.
then when to use a pre-hardened mold and holder steel? Large
Okay.
molds, when we are going to manufacture a large mold,
Hmm.
or molds with low demand on wear resistance, extrusion dies
Right.
higher and high strength holder plates. So 270 to, here you can see the steel are delivered in the hardened and tempered condition, usually within the 270 to 400 BHN Brinell range. That means
Right.
Brinell hardness
Brittle
number,
hardness.
BHN. Hmm?
Yeah.
And if
Yeah.
we talk about the HRC, then the hardness will be somewhere around 40 to 45 HRC.
With the mold plates. Mold inserts.
with the whole mold actually.
Okay, okay. 40 to 45
Die
HRC.
and core and cavity part, those are the
Yeah,
two.
we'll have more. Yeah,
Those core and cavities will be around somewhere
right.
40 to 45 HRC harden.
Okay,
Okay.
okay.
The surface hardness can be increased in many cases. Why heat? Okay. Here they have some reason when to use through hardened steel. Okay, so
Right,
for long productions runs, when you are
right.
like going to manufacture some plastic bottles which have a long range of
Yeah,
production line, so at that time we go for through hardening,
okay.
where a bulk of mass production is required.
Mass production. Yeah, yeah.
We go for through hardening steel, through hardened steel.
Okay,
And
okay.
to resist abrasion from certain molding materials, counter high closing or injection pressures, because we apply a lot of pressure at the time of plastic
Right.
injection, so the material, the die in the core and cavity should be strong enough to sustain that pressure.
Yeah, yeah.
For high pressure processes like compression molding, this is also because in injection molding we don't apply that much pressure, but when we talk about pressure die casting, the pressure is very immense
Yeah, yeah.
at
It's
that
very,
time.
very, very high. Yeah.
Very high, and your mold material should be strong enough to hold that pressure and
Okay.
continuously,
Yeah.
because you are also
It's
pouring the very hot material like around
hot
uh,
material.
900 to 800 degree centigrade of aluminum is pouring inside the mold, so the mold temperature is
Right.
also increasing, but
Yes, yes.
at that time the increasing temperature should not affect the strength of the mold itself,
Right.
otherwise
Okay.
the mold can open, mold can twist, anything can happen.
Right, right.
So the mold should
So
be,
temperature variation is continuously happening on the mold.
yes, yes, continuously happening. Because of that, we go for some alloying elements like chromium, like tungsten. We use these
Tungsten,
elements
yeah.
in our molding material, so that because they are
Right.
heat resistant material,
Okay.
like
Yeah.
tungsten and chromium. These are heat resisting material,
Right.
so that the mold don't lose its strength at a very high temperature.
Right.
Okay.
Okay.
The steel are delivered in the soft annealed condition. They are usually rough machined, stress
Right.
relieved, semi-finished machined, hardened and tempered to the required hardness, and then finished machined, ground and often polished or photo etched. This is important. I will tell you. Okay, so what happens when we start machining? We take the raw material and we go for,
Right.
first of all we go for rough machining. Okay,
Yeah.
we go for
Yeah.
rough machining, so there the depth of cut is high, like 0.5 mm, 0.6 mm. We go for 0.6 mm, so that the process should completed in a short time. Okay,
Yes.
and
Rough machining.
rough machining, rough machining.
Yeah.
So at that time what happens, the load on the cutter is very high, because we are taking very big depth of cut like 0.5, 0.6 mm.
Yeah.
Okay,
Yeah.
so at that time what happens, the material inside the material, very there are many residual stresses generate inside the material of the mold.
Right.
Okay, because
Right.
of that,
During machining.
because of the machining, because the cutter is rotating at around 1400 or 1500 rpm, and we are going to get
Right.
very big depth of cuts. Because of that, many residual stresses remain after the machining, rough machining. So
Yes.
what happens at that time, we go for stress relieving after the um, uh, after this rough machining.
Right.
The part
Right.
can be twist, part can be like
Yes.
deform in a different
Bent.
form, bend, maybe bend.
Yes. Yes.
So what we do, we go to release these residual stresses. At that time, we
Right.
go for annealing or tempering. So
Okay.
or normalizing. So what we do, we in the annealing process or normalizing process, we
Yeah.
heat we heated the component in a moderate temperature, okay, and then
Yeah.
we cool it down in open air,
Okay.
so that when we heating up the material, heating up the
Yeah.
die and core, the stresses are relieved. All the stresses,
Okay.
residual stresses because of the machining, are relieved when we go for a moderate heating. Okay,
Okay.
then we
Okay.
bring the material again, bring the, the rough machined component again, and go for
Yeah.
small cuts. Like if after that we go for semi finishing, and then after that we go for finishing of the material. Okay,
Right.
so in semi finishing
Okay.
we hardly give zero point 0.1 to zero point 0.2 depth of cut.
Yes.
So
Yes.
at that time residual stresses don't create.
Okay.
These stresses are created only when we go for higher depth of cut.
Right.
Okay,
Right.
point one is and we also in semi finishing we also increase the RPM of the machine, RPM of the cutter, like we go for 2000 up
Yeah.
to 2000 RPM. So stresses don't create at that time, residual stresses.
Right.
So and
Okay.
after that what happens when we go
Mm-hmm.
when we did semi finishing,
Yeah.
see when we go for rough machining we leave at least 1 mm of extra material, part stock.
Okay.
At
Right.
least 1 mm of part stock we have to leave for the semi finishing and for the finishing.
Right. Before we do the stress relieving,
Before we do the stress relieving, we actually
we
the
keep an extra material for the
uh,
semi finishing.
yes,
Right.
keep at least of 1 mm, because there are many
1 mm.
stresses are there over there, so the material can deflect from its original shape. So for that purpose, to encounter that deflection, we leave at least 1 mm of extra material.
Okay. Okay.
ठीक है? 1 mm of extra material, and then we go for
Hmm.
semi finishing. Over there we leave at
Right.
least 0.2 mm of extra material for finishing
Okay.
purposes. 0.2 to
Right.
0.5 mm. It is somehow range actually. We cannot say
Right.
we have to leave only 0.2 or we have to leave only 0.5. This is the range, 0.2 to 0.5 mm we have to leave for the finishing purpose.
Right.
Okay, so at that time what we do when we
Uh-huh.
have done semi finishing,
Yeah.
we go for after that we don't go directly for the finishing process, we go for hardening process after semi finishing.
Okay.
We go for
We go for through hardening.
through hardening, yes, because
Okay. Okay.
over there are the material can bend also, because when we are going to induction hardening, then
Hmm.
we put the whole die or core or cavity on two stands. So there could be a bend because of we are heating it up to 900 to 1000 degree. So
Right.
there could be a bend appear. So to encounter that bend, we leave some extra material, that when we will bring the part for the machining, we will first of all we will clear that bend, and then we will go for finishing process.
Okay. Okay. Yeah. Because of this residual stress.
No. Here residual stresses are not there. Here this is the
Yeah.
criteria for
Even
bending.
yeah. Even in through hardening, you will come across bending and deflections.
Yes, deflections and bendings are always there after the through hardening, because we have
Right.
applied so much temperature that the part can
Hmm.
deflect from its original shape. So
Okay.
we
Okay.
encounter that remove that deflection with the help of machining, with the help of
Right.
we always use many gauges which tells us that how much is the deflection, how much is the bend, and then we remove that bend with the help of grinding. Not with the
Right.
direct machining we go for, because the bend is hardly 0.1 to 0.1 to 0.2 mm. Bend is not
But
that
on
much,
a
like
long
1
plate,
or 2 mm is
it'll
not the bend.
matter.
Yeah.
But on a big plate, on a big die plate or something,
Okay.
a small bend, a small deflection can be a big variation.
Yes, yes, small. That's the thing, that we always try
Yeah.
to remove that bend, that deflection after the heat
Right.
treatment process.
Right.
Okay.